Good morning, sir.
Good morning. So exactly at 10 o'clock we'll start. Fine.
Okay, sir.
So let all students join. So many new students are joined. Those who have not joined yesterday. For them, it's advisable to. We have already given the link of the YouTube for the yesterday lecturer, yesterday sessions lecturer videos. Fine, you just watch that one. And number two, we have to complete the Python today. So today we have two sessions are there. One is your data structure in Python and OOPS using Python. So today we'll complete that one. Then tomorrow in first session, we'll discuss about this data science as machine learning, how Python is useful there. And the second session tomorrow is your mini project. Fine. So this is the schedule for today and tomorrow. 19 student has already joined. Just wait for another 2-3 minutes. Exactly at 10 o'clock we'll start.
Okay.
Just wait.
Sir, in case there are some concepts that we can't complete in the two sessions, the two morning sessions, can
So
we
in
just
doubt,
move it to the
yeah, in
evening?
doubt clearing section, doubt clearing session, we'll try to complete it.
Okay, sir. Sir, shall we start the session?
Yes, we'll start. We should start.
Okay.
Okay. So once again, welcome to all. So now for the day 2, session 1, we are supposed to discuss about the data structure in Python. Okay, Devalina ma'am, you can start.
Yes, sir.
Let me make you the co-host. Just a minute. Yes, you can share the screen now.
Okay, sir. Is it visible to all?
Yes.
A very good morning and welcome to all of you for our next session on day 2 of your Applied Python 1 workshop. What do you think of Python now? How does it feel after learning some of the basic Python concepts? I think you must be feeling confident about it, right? So I'm really sure that now you find Python programming language a whole lot interesting, which is why in today's session, we will take our discussion one step forward. We are going to learn a lot of exciting concepts today. So keep your Google Colab notebooks ready. And before we begin, let's go through the agenda of today's session, as well as a recap of day 1. So in today's session, we are going to discuss functions and loops in Python. Then we are going to discuss some of the major data structures, or you can also call them as data types in Python, that are used to manipulate data, like lists, tuples, and dictionaries. So in yesterday's session, we discussed about conditional blocks, your if, elif, else blocks. So the syntax follows as if, condition 1, then you have some statements within your if block, followed by elif, condition 2, where you have the elif block. If none of these conditions satisfy, if condition 1 and condition 2 evaluate to false, then the control passes on to the else block. Then we execute the else block. So if, elif, else statements are used in Python for decision making. So when we have multiple conditions and based on those conditions, we have to take a decision, that's when we use this construct. For those who could not attend yesterday's doubt clearing session, we also discussed some comparison operators. So these operators are given as follows. So number 1, we have the double equals to operator. When we write x double equal to y, we are trying to check whether the value of x is equal to the value of y. When we have the exclamation followed by an equal to, it is a not equal to operator. So we are trying to check the condition whether the value of x is not equal to the value of y. Similarly, we have many other operators like greater than, less than, greater than or equal to, less than or equal to. And these operators come very handy when you are using your decision-making constructs. In if-else conditions, you can use these operators to write your conditional expressions. Next, we had logical operators. So these logical operators are just these 3, and or not. And is used to check whether both the conditions are true. If and only if x is less than 5 and x is also less than 10, then this expression will evaluate to true. In or, when either of the conditions are true, the entire expression evaluates to true. Either x is less than 5 or x is less than 4. If any of these two conditions are true, then we have the entire expression to be true. The final logical operator that we have is not. It is used to reverse the result. When we add not in front of any condition, then whatever the value of this condition is, it will just print the reverse of it. So suppose that we have x less than 5 and x less than 10. If the value of this expression comes to be true when we add not, so it means not true, and the final value of your expression will become false. Before we move on to functions, we'll just have a quick recap of all the different things that we learned, all the different coding concepts that we learned yesterday. So this is my Google Colab notebook for people who have joined today for the first time. All of our programming assignments and all of the program executions shall be done on Google Colab notebooks. So just try to log in into your Google accounts, and from there you can access the Colab notebooks by going to the link colab.research.google.com. Fine. So first thing that we learned yesterday was our hello world statement. And how did we do that? So we just used the print statement. We printed it out. And now we have also learned what is a variable. So the syntax of declaring a variable is we write a variable name is equal to some value. So we also have gone through some of the naming conventions of the variable name. So I won't discuss them again. Keep your variable names a combination of your alphanumeric characters and underscores. So that's one of the thing, and don't start any of the variable names with a number. So let's execute this code. Motivation is equal to, I have taken my first step towards learning programming with Python, and we print this motivation. So I hope that you all are equally motivated and ready to launch into Python programming. And the next thing that we learned was data types. So we saw 4 types of data: integer, float, string, and Boolean. So over here we have 2 types given, the integer and float. Float includes the real numbers, integers just the integer numbers, like all the positive numbers, negative numbers, and 0. So let's print this out. So date equals 28. We also have this expression over here. If you remember typecasting, 1 is automatically promoted from integer to float and added to get the final solution. Then we had some mathematical expressions as well. We also worked on our own mathematical expression using all of the operators that we have. So over here we have one combination of numbers and operators. 5 plus 2 multiplied by 10 minus 4. That gives you 21. Next.
Ma'am, could you explain the previous one, the float and integer?
This one?
Yes, ma'am.
Okay. So here we have date equals 28. That is your integer type. If you just check this one, type of data. So type is a function in Python that allows you to check the data type of any variable or even of any value. And here we have ours, which is another variable. It's storing. So here we have 2 floating point data, 1.5 plus 1.5. But over here we have an integer. Python has a concept of automatic type promotion, which is also called as implicit typecasting. And using that, we can, any operation that you have in Python, it has to occur between the data having the same data type. So if we are using addition, so all 3 of the numbers should belong to the same data type for this addition to occur. So 1.5 plus 1.5 plus 1, all of these have to belong to the same data type. And now we have 1.5 as the float and 1 here one is the integer. So we have automatically Python promotes this one to 1.0. It is happening behind the scenes. We do not even get to know about it. So this is your implicit typecasting, and using which we can easily work with integers and floats. I'll also revisit some of the concepts related to type conversions. So there's this part. I hope it's almost clear. I think you did
Yes,
not
ma'am.
end the session yesterday.
I did, ma'am. I did.
Okay, okay. So in the doubt clearing session, we had gone into much detail on this part. Fine. Now we will add strings together, which is also called as concatenation. So just run this statement. So we get A, B, C. So in strings, we do not have any particular addition operation. Instead, we have the concatenation operation. The next part is your implicit type conversion, where the interpreter is automatically promoting your integer 5 to a float and then adding the numbers. So when we write 5 plus 2.5, 2.5 is a float and 5 is an integer. But due to implicit type conversion, 5 is automatically promoted to a floating point, and there we get our final output, which is 5 plus 2.5, 7.5, which is a float. I hope this example explains it a lot clear. Fine. Next, we go to some of the string and integral data types. So we define a variable var equals 28, and we print today's date is plus var. What are we trying to do over here? We are trying to add a string and an integer. So can we do that? Let's see. So we have a type error, which says that can only concatenate string to a string. So now Python interpreter is thinking that we want to use a concatenation operator, which is also true. We want to concatenate the two, but we cannot concatenate an integer to a string. So what change can we do over here? We can use explicit type conversion. We can convert the integer to a string. So let's execute this code cell. Today's date is 28. So now, are you all able to understand the type conversion concept? If there is any doubt, please let me know, because a lot of other things we are going to discuss today. So this thing needs to be clear. Okay. We have another example over here. Print 2 raised to the power of 10. So we saw one operator to the power of, which is given by double star in Python. So for that purpose as well, we cannot concatenate a string to an integer. So now we have to convert the value of this expression into a string type. Let's execute this. 2 raised to the power of 10 is equal to 1024. So when we are using certain functions like str, or we are converting explicitly, stating like int or float, when we are using it on our own and it is not being invoked by the interpreter, that's when you can sense that it is your explicit type conversion, because you are explicitly mentioning. Okay. Moving on, we saw just now we have lots of conditional operators. So the return value of these conditional operators are Boolean types. So when we check the condition 5 greater than 10 or 90 greater than 100, we are trying to evaluate either one of the two conditions has to be true. The first condition, 5 greater than 10, this is going to evaluate to false. But the next condition that we have, 90 less than 100, it is going to evaluate to true. So Here we have one of the expressions getting evaluated to true. When we execute it, the value of the entire expression becomes true. If we use and over here, we will get false, because and requires that both the conditions have to be true for the entire expression to be true. And one more thing, we'll also see the usage of not. So remember that the value of this expression came as false. And when we use not, we are trying to invert it. So what will happen? Not false becomes true. Okay. Next, we move on to branching. So branching is the decision-making constructs that we discussed yesterday. The statements inside the if block get executed only when the condition evaluates to true. So let's see that age equals to 20. If age greater than or equal to 18, print you are eligible to vote. So over here, when we try to evaluate this expression, the value comes as 20 greater than equal to 18, which evaluates to true. That's when the conditions inside your if block will get executed. You are eligible to vote. So suppose we want to try some other number. What will happen if we write 17 and we try to execute it? Well, nothing got printed. Why? So if condition evaluated to false, nothing happens. But we don't even have over here an else block. So when a condition evaluates to false while we are using if, we have an else condition to at least print out a message to the user saying that your condition did not work out, your condition is false. So for that case, we can write the else block. So over here we have one else block saying that you are not eligible to vote yet. So this condition will be executed when the if condition evaluates to false. So let's execute this. Yeah, you are not eligible to vote yet if you are of the age below 18. So what if there are more conditions? We saw that we have another keyword, which is elif. So how are we going to use it? So if the this condition evaluates to false, we want to have some other conditions that we can check. Suppose we have age greater than or equal to 18, which says you are eligible to vote. We also want to have another condition, age greater than 18 and age less than 25. I think this won't work out, sorry. Age greater than, age is less than 18 and age is greater than 6. And we will print out a school student. Or else we print out you are not eligible to vote yet. Let's execute this part. So first, when we have age equals to 24, you are eligible to vote. Now let's change age to 17. We print out a school student. So you can see that when the first if condition evaluates to false, because 17 is not greater than equal to 18, it is less than 18. So this condition comes as false. So we go on to the next condition that we have over here. We check this condition and it evaluates to true. In that case, we print hey school student, or else we print out you are not eligible to vote here. So don't try to make a literal sense of this function. I'm just trying to explain you how the conditions are getting evaluated. Suppose we have age is equal to 3. And in that case, you are not eligible to vote yet. Well, of course, you won't be eligible. So these are the control flow in your if, elif, else statements. So after revisiting all these concepts, we have another concept which was called as taking user input. We have the input function in Python, which is used to accept user input from the user through your IPython console or wherever you are executing a code, you always have the prompt from where you can enter data into your program. So we have this variable called as energy level, and we want to input a value. What's the value of an energy meter? So this, when we execute the input statement, the input that is accepted is in the form of string. We need to typecast it in order to perform mathematical operations. So for that, we use the int function of int over here to perform explicit typecasting, which is why one of the reasons that I was emphasizing a lot on typecasting is we are going to use it a lot from now onwards. Okay. So I want you all to comment, what's your energy level? So we are going to start our day 2 session, and how are you all feeling? How are you all, like how motivated are you to learn Python further? So just comment in the chat box, what is your energy level? Is it greater than or equal to 100? Or is it less than 100, but yeah, greater than 80? Or is it less than 80 and greater than 50? Or even if it's less, just be honest, just comment it out. What's your energy meter? People just try to be interactive. Um, so sir has
Be interactive. What happened? All of you are silent.
sir has energy level 200.
Yes, yes.
Okay. Greater than 80. Punyatoya, she says 100. Samvedana, 100. Devi Shri, greater than 80. Okay. 100. Ananya, 90. Swapna, greater than 80. Kuldeep, 100. Vipul, greater than 100. Great. Ankita, 100. Roshan, 100. Great. So try to be more interactive in this class. This is a mutual learning session. Even I'm learning along with you. Yeah, great. So we try to execute this code right now. And we take the user input. So for this, we have what's the value of the energy meter. So as sir said, I'm going to enter 200. Ready, get set, go. So with this, try to increase your energy level and try to be more interactive in the class. And kudos to those who even said honestly that it is, yeah, greater than 80. Well done. You'll get close to 100 very soon. Those of you who are still trying to stay motivated, just be more interactive in this session and tell us if you are facing any issues, or even if you need some motivation, we are here to provide that. So be a lot more interactive in this class. Next, we are introducing some new concepts. So over here, we have something called as the none keyword. Whenever you want to define any null value or absolutely no value at all, so we have this particular keyword. When we write x equals none, we print the value of x. So it is NONE. So this is a keyword in Python. It is a data type of its own. It is not same as 0, false, or an empty string. So this is something that you need to remember. Don't worry, we will see it in action in when we are going to proceed on to functions. We will see what is a none type and where we encounter it. So that is one of the things that we'll see. This is just a preliminary concept that you should know before we go on to the some more complex things. So now we officially welcome you to day 2. We are done with the revision, and we also experimented with some new types of coding constructs. And by now you are equipped with a lot of tools. You know variables, data types, you know how to print how to take input from the user, a lot of mathematical operations, conditional operators, you also know logical operators. And now using all those things that you have learned, we are going to proceed further into defining functions. So let's see what is a function. A function is actually a block of code which we are writing in order to perform some specific task. This specific task is based upon what the user wants to do. So this is the syntax of a function. We use the def keyword to define a function. So we write it as def function name. Then we have your parameters. And the list of parameters is also optional. Some functions can accept parameters, whereas some others, they do not have parameters over here. This is followed by an indented block. So just like you saw in your if, elif, else statements, here we also have an indented block. As we had said earlier, indentation is extremely important in Python. And for each and every construct that you are going to write in Python, you have to take care of this indentation. When you are using an IDE, when you are using Google Colab, that will happen automatically. However, just remember that it's a very important concept. Okay, so this block of code that we have over here is called a function. And also return is optional. So a function can either return a value or it may not even return a value. So over here, return and the parameters, these are optional, but these are a part of the syntax of a function. You can have it or you may skip it over here as per the requirements of whatever task you want to execute. Fine. So this is the syntax of a function, and we'll see a lot of examples for this as well. Without a return statement, how are we going to execute a function? So we write this simple code, and I will ask you all, just go to your Google Colab and type in this code and see for yourself what is happening. So we have def greeting. Greeting is the name of my function. Def is the keyword which is used to define the function. Here we have a parameter. This parameter is called name. Then we have one statement inside the function, print hey plus name. And then we call this function like greeting, and we pass some value to the function. So over here, I'm passing my own name, Devolina. And the function is printing out, hey, Devolina. So all of you just write this small snippet of code in your Colab notebooks. Try to execute it. So over here, we can call this function multiple times as well. So if you want to print the greeting again and again with different names, so you can have greeting, and you within quotes you can write your own name. So it will print the greeting with your name. Okay, one person has already executed this. Okay, the rest of you keep trying, try to execute this function. If at any point of time there's something that you are not able to understand, feel free to write it into your chat box. If we are able to clear your doubt now only, then in the doubt clearing session, we can learn something more. Yeah. Okay. So a handful of people have already executed this. Okay, now the next thing that you can see is the return value. So we can clearly see we have not used any return statement over here. This function has no return value. So what if we try to access the return value from this function without even knowing that this function has absolutely no return statement? So we experiment with that. Here we have defined a variable return underscore val and equals to greeting Devolina. When we are calling this function greeting with the string Devolina, it is printing out the message, hey Devolina. And whatever is the return value that we get from this function is getting stored in your return value variable. Now we print out what is the contents of this return value, and we see it is none. So just now we discussed the none type. When the function has no return statement, and if we try to execute that, ideally it should not be done, but just for the sake of the concept, I have written such statements. So we print the return value and it comes out to be none, meaning that this function does not return anything. And none is one of the types which is also enforced by your interpreter, and it is by default. So if something is empty, if we try to get some return value, especially in the case of functions, the value that is returned by our interpreter, that is none. Okay. Excuse me. Moving on. So now we have a small function definition. This function is trying to check whether the number that you passed to the function, is it positive? So we keep our function names descriptive as well. Similar to a variable names, we want to have descriptive function names so that we can understand what task we are trying to accomplish using a function. So again, we use the def keyword. Def is positive, and then we have a number. If the number is greater than 0, we print out positive and we return the value true. Otherwise, at any point, if this condition is not satisfied, we return false. So when will this function return false? When the if condition is not getting satisfied, if the number is not positive. In that case, the control will automatically be transferred to the next statement. The next statement will get executed, and that's when we have return false. So it is more like your if else construct that you have. Here we have omitted the else because we don't really need it. For ease of execution, for ease of understanding, you can have your else statement. You can write an else block, and then you can over there you can put this statement return false. However, for ideal programming, it is not really necessary. You may not have your else construct over here. If the if block evaluates to false, automatically the next statement will get executed. Otherwise, when the first return statement is encountered in your function definition, so that's when the execution of the function will stop. The moment the number is positive and we get it that yes, the number is positive, it will get printed out positive. Immediately the function will return true and the execution will stop. So this is the point where the execution of the function will come to an end. So we can call this function like is underscore positive 10 and the value comes out to be true. Okay, so someone is asking me to explain the none part. We'll explain it using one example. So just let's see. Let's go back to our Colab. So we have different types of functions. The first type that we have is no parameter and no return. So let's execute this. Def my function print hello world. So this is the hello world of your functions. And we call this function using the function name. So we can call my function hello world. And that's when the statement inside your function gets printed out. The next, okay, so all of you, if you still have any query regarding functions, try to write a very simple function where we have no parameters, and no return. A simple printing statement is contained within this function. The name of this function is my function. Again, we can see the def keyword is used to define the function. And we can call this function using the function name. Okay. So from a function's perspective, we have a parameter and an argument. A parameter is contained in this part. When we have the function definition, the function name, here we state our parameters. And when we want to send some value to the function, here we have your arguments. So these terminologies should be clear when we are working with functions. So whatever values, whatever list of values that we may pass to the function within the function definition, here we are calling those values as the parameters of the function. And when we have to pass some value to the function, these values are being called as arguments. The arguments are being sent to the function. So one is contained within your function definition, that is your parameters, and one is being sent to the function, which is called as the argument. Okay. So now that we know what are parameters and arguments, we have this function with parameter, but having no return type. Excuse me. So we have def my function greeting name. So here name is the parameter of this function, my function greeting, and we print hello name. And then we call this function with this argument. So this becomes the argument to the function call. And here I am passing my name as the argument to the function, my function greeting. And then there we go. We have the output, hello, Devolina. You can also call this function multiple times. You can write repeated statements, and it will get executed each time you call it. Hello, name 1, hello, name 2, hello, name 3. Fine. So all of you have written the greeting function, I suppose. So next, we will see the return type for the function. So here we have a function called as my function greeting, and we want to see the return type for this function. So we don't have any return statement, right? Now we want to have something called as the return value equals to my function greeting. And then we want to print this return value. So when we call this function, the function gets invoked, and whatever statements, whatever the work of the function is, whatever statements are contained within that function, they will get executed. So we have this statement getting printed over here, hello, Devolina. Now we want to check what is the return value of the function. Did the function return something? And if there is no return statement, it will return this value called none. None means there is absolutely nothing, nothing, nada. So that is your none type in Python. And just like we have different data types, we say that when we see 5, we immediately recognize, okay, this is an integer type. When we see 2.5, we say that this is a floating point. So none on its own, it is a data type. You can think of it as a data type in Python, just one single value belonging to this particular data type, which is none. It's absolutely nothing else. There is no other further use of none. This only occurs when we have to check for return, or if we want to even assign to certain certain value. Like if we write to a variable, if we write x equals none, it means x contains nothing. It is none type. You can see over here as well, it is none type. And then we print x Okay, so this is a value, a particular value in Python, and it has some limited usage. So this is one of the places where you may encounter none, which is why I discussed it with you. I hope it is clear now. To the one who was asking this question, please let me know.
No queries in the chat box.
Excuse me, ma'am.
Yes.
To me, it was showing that my function greeting is not defined. Like I did that dev greeting name. That one was okay, but I tried this my function greeting, saying that it's not defined.
Is your
Showing
function similar to what I have written? Can you just copy paste your code in the chat box?
Okay, ma'am, I got it.
Oh. Fine. So we'll see one more function over here. So this function contains parameters. It also has a return type over here. So this function is, so we write this function to compute the sum of two numbers. The two numbers that we have are being denoted by parameters a and b. Within the function, we have another variable, add equals a plus b, and then we return add. Now the value that is returned by the function, we have to store it somewhere. So in order to store this value, we have another variable called as sum1. Sum1 is equal to sum of two numbers. Over here, we are calling the function. So we call the function using the function name. We have the function name and we pass two arguments to this function. These arguments are 5 and 10. So 5 goes to your variable a, sorry, we can say the parameter a, not essentially a variable, it's a parameter a. These are like placeholders. And 5 goes to a and 10 goes to b. So whichever order you pass the arguments, that will get accepted as per the order of the parameters. Next, we return add. So the sum of the numbers has already been computed. It is stored in this variable add. And now this value is passed on to the function call. So now sum1 contains the value returned by sum of two numbers, this function. And this value is the addition of the two numbers. Now that we print out sum1, we get 15. Okay, we can change the values. We can have 10, we can have 20. And again, we can print the sum of these two numbers, 30. So since we have Python to be dynamically typed, it's not necessary that we have to perform this addition only using integer. So let's try with some other data types. Let's try with floating point numbers. 10.5, 20.6. And let's print this out. We change the name of the variable. We want to have sum2. So we have 31.1. So you can see that when we write one function, there are a lot of chances that we can reuse it for multiple data types. So especially functions such as performing some mathematical operation, we can work on it using integers or floats. But what will happen if we use a string? String does not have addition, but it has concatenation. So let's try that out as well. But although the function says sum of two numbers, what if we try to be mischievous and pass into something else? Okay, so we have hello world. Let's try this out. Yep, it works. It works, and it gives you the concatenation of the two strings that you passed onto the function. This is one of the reasons why we have to keep our function names descriptive, We want to tell the user what we want to perform with this function. So I am explicitly saying that this is sum of two numbers, A and B. So that's how the user will understand what are the arguments that need to be passed. Okay, so has everyone been able to understand how are we going to use a function? And with parameter, with return, this particular part. Try to execute it on your Google Colab notebooks. See for yourself, experiment with the code and see for yourself, at least try one or two function calls and see how the values are getting better. I'll also add one more function type over here, one more function call. So let's try having sum of two numbers and a mix of two. So if I have 2.5 and if I have 5, I have some 4 and some 4, and just execute this. 7.5. It works perfectly. And we have created this function essentially to perform the addition of two numbers. These two numbers can be anything. However, we tried to just be more experimental and we wanted to see if it works for other data types. And we saw that yes, it also works for strings. So for strings, the plus operation becomes your concatenation. Okay. What about others? Alicia has already executed this code, I think. Okay, that was a previous message. Okay, Roshan, done. Others? Done. You can do a whole lot of things with functions in Python. It is one of the most powerful constructs that we have in this programming language. Okay. Others? This function definition with parameter with return is the most widely used. Most of your functions will have a return type. When you use your print functions, when you use our input functions, those are also functions which have been inbuilt within Python. And now we are proceeding towards writing our own functions. Isn't that interesting? I'll just have a sip of water before we move on to the next phase. Okay. So most of you have already executed the functions. Well done. So from now onwards, we are going to learn similar constructs like functions, and we are going to combine all these concepts that we have learned together. So now, one more thing that I will just tell you all about. This is a pass statement, a pass keyword, you can say. Suppose you want to have one function, but you have not decided what you will write within that function. So just like the one that I have over here, I have not decided what code I will write. So just as a placeholder, we are writing pass. So pass is helping us to avoid getting an error if we execute this function in Python. So if I run this function, I get no error. But if I did not have this pass function, Python would generate an error for me. Unexpected end of file while parsing, or if I just remove it completely, And I have something like this, unexpected end of file while parsing. So this is an error that comes. So you can think of a function and yet you cannot write it. So your idea just may keep floating or it may just gone forever. So for that, we have this pass statement. Whenever you think of like, yeah, I am going to work on this function, but I've not decided what code I will write inside of it. For that momentarily purpose, we are using pass as a placeholder. So now we don't get any error. Okay, so this is a function that has no content. This function is actually empty. We just have this decided that this is the name of the function, something that we want to do with a number. We want to check a number. So what are we going to check? We have not decided yet. So that's when we write the pass statement. Okay. So let's decide to do something with this function. So I want to have a function where I will check whether a number is positive, negative, or zero. So let's take this function definition and write the code for it. So how will you check whether a number is positive, negative, or zero? We come back to our decision-making constructs, if, elif, else. So remember that in if else if statements, how we used to check the condition, we first used to write if keyword, we have the number. If this number is greater than 0, we are going to print positive. Else if or elif, this is your keyword in Python. So in other programming languages, it comes as else if. In Python, we have the condensed keyword, which is called elif. And if number is less than 0, we print negative. Elif, if number is equal to 0, we print number is 0. So that's a function definition. Now, we want to check the number. And note that this function is not returning anything. So we have check number. And over here we pass, suppose we pass 5. And then we have positive. 5 is a positive number. Now we want to change it to -9. It's a negative number. Similarly, if you want to check if all the conditions are working, check number 0. So we have number is 0. So even within functions, so now we are combining the concept of functions that we learned and the concept of if else if statements that we have learned previously. So we are now just proceeding further. We are combining the concepts and building more powerful functions. Try to work this one out on your own. Okay. Is anyone executing this one, or should I proceed further? Did you try to check number? Were you coding along?
Yes, ma'am.
Okay. What about others? I'm getting responses from the same people, same group of people. Others who haven't interacted in a while, just at least comment in your chat box. Okay. All right. So yesterday we were building a calculator. So this the calculator that we were building, it was based on if, elif, else statements. Now we are going to build this calculator using a function. So now you have learned the functions, and now we can use the same concepts. So I was getting this question. I got this question in two of the sessions. How we can implement the calculator with switch case. So in Python, we don't have a switch case, but we can implement it. Anything which is not present in Python, it does not mean that it is like nullified. It is not there. We can always have our own user-defined implementation for the same. So here I am defining a switch case like functions, a function which is similar to how a switch case would operate in other programming languages. And this is one of the easiest ways to implement a switch-based construct. What I have over here, switch, it is a data type or a data structure in Python. This is called as a dictionary. Don't worry if you cannot get any one of the concepts if you are not able to understand. Don't worry, because we are going to explain all the different kinds of data structures available in Python. But for the moment, just follow along, and it's just using the concept of functions. And just one thing which we have not previously discussed is your dictionary data type. So here we have defined a switch, and we take the user input as the operator. So what operation do we want to perform on the numbers that we are giving as input? The first one was plus, and when we have the plus operator, we are performing the addition. Over here, I am performing num1 plus num2. If we have minus, subtraction. If we have multiplication, it's multiplying the two numbers. For division, we have division of the two numbers. And finally, for modulus, we are trying to compute the remainder when the two numbers are divided with each other. So we are also using one inbuilt function, which is present in your dictionary class of Python, switch.get. So when we are writing something like switch.get, we are passing the parameter. This parameter is our operation. This value, this is a placeholder, and the value, the argument that we are passing when we are calling this function, we are passing the operator. So we are invoking the function using the function name calculator, and we pass the operator to this function. So now param, it holds some operator. It's either plus, minus, multiply, divide, modulus. And when we write switch.get, it goes to the operator that we are passing to this function. So suppose that we have passed plus. So in switch, it will go to plus. It has the addition of two numbers, num1 plus num2. Immediately at that point, it will compute the addition of the two numbers, and it will give this value to us. So this is the value which gets returned from the dictionary, what we have called as switch. It will return num1 plus num2, given that we have passed a plus operator. We also have something like none over here. We'll get into that later on. So just execute this part. Enter the first number. Enter the second number. Enter the operator. So if I want to have multiplication, I get the output as 50. So we are not using here if, elif, else conditions. We are trying to simulate a switch case, and we are using a dictionary for the same. Okay. All right. One more thing that you may note, I have used global num1, num2. What would happen if we comment it out? 5. Okay. So over here, we have global scope for the numbers. I wrote it explicitly over here. However, we don't need to have this. We will use the scope of variables when we discuss classes in an object-oriented programming. But here, when we have a function, it is defined within the entire program. So it can access whatever values are available outside of the function, that uh, that should be able to access. Okay, so let me just change. I think I defined the global scope, which is why this is happening. I changed the name of the variables A and B because I think it should not work in the same way. Okay, so a lot of changes are required over here. So just let me see. If you are interested to write your own calculator in this manner, you can simply work it out. A lot of things will become clear when we work, when we explain those data structures in Python. Okay, 10, 5, 50. So now we verify that yes, these variables are having a global scope. So these variables A and B are accessible throughout your function. Okay. But one more thing, do you think this switch, what we have defined over here, this dictionary, will it be accessible outside the function? I'm looking for responses. What do you think? Will it be accessible outside the function? Yes or no? Just type in your response.
Yes or no? Tell.
Okay, Roshan says no. And no. Others? So just try. If you are not able to come up with an answer at that moment, just try it out. Try it out. Is it available? So Python says name switch is not defined because switch lies within the scope of this function. So just like we were checking whether these, whether do we need to have global or are they already global? So we came to the conclusion that yes, they're already global. These variables are accessible throughout your function. But is the vice versa true? Is the variables that we define within the function, the data, when whatever data that we store within the function, are those particular variables accessible outside the function? So the answer is no, they are not, because they lie within the scope of this function. Once this construct is over, after that you cannot access that. So switch has local scope. Local scope means it is accessible only within certain boundaries within that function. Okay, so that was a whole lot of new concepts that you learned so far. And another thing that you have to understand, I did not discuss it yesterday, but you can just try to map all the concepts that you learned in primitive programming languages like C or C++, or even in Java. In C, we have a main class, a main function. In Java also, we have a main function, which we define as public static void main. We have the main function. And in C++ also, I'm not really a C++ programmer, but I really hope that we also have a main function in C++. So main function is widely used across all programming languages. And even in Python, we can have the same. Suppose we want to have a main function, we want to write a Python program in the traditional method. So we have defined a main function over here, def main. And we write, this is a docstring. If you remember when we were discussing comments yesterday, we had single line comment, multi-line comment, and we also had something called as the docstring. So we can have 3 quotes. You can surround your text with 3 quotes, and you can write the definition, whatever definition of the function, as in what task you want to accomplish with this function. So here I have written my first Python program, and we want to print hello world through this function. Now, when we have a main function, it has to be invoked from some place. So to invoke this main function, we are first checking if name equal to main, then execute the main function. So these are some new concepts that you have to know about. So we have this special variable within Python. This special variable is mentioned as __ name __. So this special variable helps us to store the value uh, of the current function that we have, the running module that we have. And we are checking whether it is the main function that we have over here. So if the Python interpreter, if it senses that the current module that you are running, the module as in the source file, the file that you are running, it is your main program, then it will set the name variable to have a value of main. So we are just trying to invoke your main function. And for that purpose, we are checking whether this lies within your main program. And if yes, we are executing it. So yeah, it got printed, hello world. This is the ideal way in which you would write your hello world program as a program. Yesterday we were writing more scripts, but if you want to have an entire Python script, like if you want to have demo.py, the type we discussed in yesterday's evening session, we were discussing how to execute Python scripts, and I showed you the Spider IDE environment where we have the .py file available. So in .py file, you can store this as a program and then you can execute it. So that will be your solid Python program in a traditional programming way. Try to execute this on your own. If there's any doubt, let me know before I proceed further. Dipanvita has already executed. Well done. Others? So in Python, we have lots of environment variables. When the interpreter is executing your code, it is setting a whole lot of environment variables or parameters which you are not able to see, but we can access them. So one such special variable that we have, that is your name. And within that, the interpreter has already stored this function which you have defined over here, the name of the function. But the way it stores it is as this __main __. So when we just check that, are we in the current environment? Are we executing the same code in the same module? When we are running the same module, we just invoke the main function. Okay. So let's go ahead then. One more thing, what you comment in on your functions, this docstring that we have, it also has special usage. So when we have this docstring, we can write help main, and on this, the output will be help on the function. And this documentation that you provide inside your main function, that will get printed out. So it's very useful if you have other functions like over here, we had a function to check number. You can also have one docstring and write some description about the function. So in this function, we are trying to check whether a given number is positive, negative, or 0. This is my docstring. So now, after we define this function, if any user wants to know what is this function about, check number. What are we actually checking? So the user can write help check number. And now we have help on function check number in module main. So you can see that by default, whatever programs that we are executing, it lies under your module main. And over here we have check number num. The function definition appears over here along with the description of the function that we just showed. In this function, we are trying to check whether a number is positive, negative, or 0. So this is the main utility of your doc strings. So when we are surrounding a description, a text using triple quotes, that is called as a doc string. Doc string. Okay.
Well, ma'am,
Yes.
ma'am, could you explain when we have to use underscore?
This one. Okay. So we don't have to use it. In Python, all your programs are under the main function by default. It was just a way of telling over here when I have written here, I am explicitly defining a function called main. I am naming a function called main, but the actual name of the module is this underscore underscore main underscore underscore. It's a special way to define the module. So you can see if we can have any other function as well. So I can have something called as def print hello and print hello. Let's try this. See for yourself. So now we have changed. So it is not a main function like a main keyword that we have in other programming languages. In Python, we are only simulating the concept. We are recreating that concept that we have in traditional programming languages. But we don't have it as a keyword. We don't have something called as main. Whatever programs that you write in Python by default, it is all under the hood of your main module. Okay.
Okay.
Okay. We are just trying to invoke it. So if my function lies within the main module, we are trying to call that function. That's it. So even if you did not have it over here, so if we just comment it out, and if you just want to print hello, yeah, it works in because it is already lying under your main module. So we don't have separate modules in Python like in other programming languages. We have some explicitly defined modules. In Python, we have a lot of freedom. We don't have to worry about a lot of different constructs or functions over here. This is just a way of writing when you are working on other coding platforms, such as if you are working on HackerRank or HackerEarth or those coding platforms. Most of the time, your programs, those questions will be mentioned in this format. You will have to complete some function. I'll show you in the evening session how we are going to work on Python programs in such online coding platforms. So this is how the programs will appear in your online coding platforms, which is why I wanted to give you all a glimpse into how it works out, so that over there you are easily able to recall these concepts. Okay, so now we proceed to loops. Till now, whatever we learned related to functions, is there any query? Whatever we learned in your functions. Okay, so since no one is having any query or there's no response yet, even if everything is clear, if you are able to understand, just let me know so that I get a clear number, like who all are confident with functions now? Okay. You get one response, two response. Okay. I know there are so many things that we have to cover in Python, but don't get afraid or don't get scared at all. This may seem intimidating in the beginning, but as you start working on your own programs, you will be able to combine these concepts into writing your own Python scripts. So even if something seems intimidating right now, just believe in yourself. You'll understand it, and you'll feel that you are able to implement these concepts on your own. And it will come only with one thing: practice. So we want you to have a prolonged practice in Python programming, and for that we will also introduce you to online coding platforms as well. We have someone. Do you want to ask some question, Bertrand?
Yes, ma'am.
Yeah.
Okay. My question is, like in the other programming languages, you write a main function where you can call it at any time. Is it the same in Python? Like if you do it the same way, you go the other one, can we call it at any time?
We can call your functions at any time. So we can even have repeated function calls. Is that what you're asking?
Yes.
Okay. So let's get back to one example. Over here, we had sum of two numbers. We can define a function and we can just keep it in our script. And later on, we can call this function as well. So it's not necessary that as soon as you define a function, you have to use it or you may lose that function. No, it will stay within your script. And whenever you want to have some usage for that function. So suppose now I want to print the sum of two integers, I'm calling that function. So anytime you can call those functions, provided those functions are present in your Python script. You can also have repeated calls. So like we had this function my function greeting, and over here we have repeated function calls. We call this function multiple times in our code, and multiple times if we call, it will always give us some output, the output that we have intended the function to give us. Is that clear?
Yes, ma'am.
Okay. Okay, so now we shall move on to looping constructs. Loops are actually used in Python to do some repetitive tasks. Let's understand that. Where do you use loops in your day-to-day life? I use loops a lot, and this loop, it comes in into action whenever I am on any music app, when I'm listening to some song and I hear some catchy track. I like to loop that song. When I loop that song, it means that I want to listen to it repeatedly over and over again, well, until I get bored. So similarly, in Python, we can have looping constructs where we are trying to perform some repetitive tasks. You need to remember that we humans, we are not really good at performing some repetitive tasks. We tend to get bored, but it's an expertise for a computer program. A program never gets bored. It likes to do repetitive tasks and it does it really well. And in using loops, we can automate all the boring stuff that we want to do. So we have two main looping constructs. We have while loops and we have for loops. So just let's see their syntax and all the implementation for the same. So this is your while loop. In while loop, we have something called as a loop variable. So over here, we have defined a variable name called loop underscore var, which stores certain value. Okay. Now we have some condition defined after the while keyword. So we use the while keyword to define the while loop, followed by a condition. In this condition, we make use of that loop variable. This is used to control the number of times your loop will get executed. Again, we have indentation. So as you can see, most of the Python scripts that you have written make use of indentation, especially when we define something like a block of code. Here we have certain statements within your while, and we have to do some operation on the loop variable. So over here we have loop underscore variable var plus equals some value. So we are adding some value to the loop variable to get to the next iteration. So in order to, we can increment the loop variable or we can decrement it. So whatever mathematical operations that you want to perform, you can do it within your while condition. Depending upon the value of this condition that you write after the while keyword, this while loop will execute some statements continuously. This happens until this condition becomes false. So it essentially means that while some condition is true, it will enter inside the loop and it will execute all the statements which are contained within the loop. You can think of it like in the case of our if else constructs, we have some condition. So similarly, now we are having this condition, the usage of the conditions in your while loops. And this is your overall syntax. Here we have an example for your while loops. So we initialize the loop variable first. See, here I have stored my loop variable I as I've initialized it as 1. Next, we have to check for a condition, and we keep repeating these statements inside of your while block until the condition becomes false. So if I write something like while I less than 5, then while I is less than 5, continue executing the statements within the block of code. At the moment I becomes greater than 5 or equal to 5, sorry, the moment I becomes equal to 5, the loop stops. It stops executing because now the condition will become false, which is why remember to increment the value of I, because it is the loop variable. It helps you to get onto the next iteration of the loop. What will happen if you don't increment this? What will happen if you don't write I plus equals 1? Anyone? Any idea? If you don't write this statement, if you don't mention this increment of the loop variable, what will happen to your code? I'm looking for responses. Yeah. Infinite loop, correct. Correct. So we will land into an infinite loop and it's a mess. So we don't want that. So for that, we have to remember that what is the loop variable we use, we have to keep incrementing it. But there are certain instances, certain programs are there where we have to make use of infinite loop. And when we have such loops, we also have certain way to get out of that loop. And we accomplish that using a keyword called break. We are going to see what break is all about. We use this keyword break to break out of an infinite loop supported by some if condition. There are many things that you can do with your loops. And before I go to the Colab notebook, I'll just ask you all, please execute this code. This is a very small loop construct that we have, a while loop example. So just see, we have what gets printed out on your screen is 1, 2, 3, and 4. Okay. Okay, so we go on to the next part, which is called as a for loop. We'll discuss the examples in the next session. I think the time is up almost. So I'll discuss for loop and I'll give you a break. After we come back from the break of 15 minutes around, we'll get into the examples. So there are so many concepts that we have discussed and it needs some time to sink in. So take your time. I'm giving you 15 minutes relaxation and after that we will come back. We have so many things to learn right now. So now we have some new loop construct. This is called as for loop. So for loop is really very useful.
Debolina, can we start the loop at 11:45?
11:55.
Time is 11:30.
Yes, sir.
45. 11:40 is there na time? Or
Yes, sir. Yes, sir.
according to our schedule.
Yes, sir.
Okay, so I think we should stop here. Start at 11:45. Yeah,
Sure,
11:40.
sir. Yeah.
Okay.
So I hope the participants have been able to understand till while loop. If there are any
Yes.
questions, yeah. If there are
You can
any
discuss.
questions, of course. Yes. Okay.
Again, we'll meet after 10 minutes. Okay. At 11:45, we'll join.
Yes, sir. Someone has posted one query. Your loop indentation is wrong. Tula, your loop increment lies outside of your while. So just correct the indentation and your code will run. Okay. So I'm then ending the session right now. Okay, sir. Okay.
Okay.